Excuse me, I'm wondering, what is probability and why am I so bad at it? Ooh. Oh, Mama Llama, it's okay. That's such a good question. Probability is real tricky, not intuitive whatsoever. So let's dig into it. What is probability? Why are we so bad at it? And what should we do with our dollar instead of buying a lottery ticket? Because that's probability. So let's use our smarts and invest that $1 because we are much better off with that. And we will learn why. Okay, here we go. Probability. La la la. Okay, so probability is the likelihood or chance of a particular event happening. And we use numbers to represent probability. It would either be a number between 0 and 1, or often you will see probability represented as a percentage. So 0% to 100%. And actually, I should do an arrow because it is a number between 0 and 1, or a decimal. So something with a 0% probability, or a probability of 0, means that event is not going to happen. There is no way that I will ever dye my hair green. 0% probability. And a probability of 100%, or a chance or likelihood of 100%, means certainly going to happen. So the sun is 100% going to rise tomorrow. Well, maybe not 100%, but close enough. Close enough. That is one of the things that we can count on. Or what is that phrase? The only things that are certain are death and taxes. There you go. 100% probability. Okay, so let's look at a couple of simple examples to understand. Now, coin tosses are a really good place to get started because there's only two possibilities, or two options for a coin toss. Either you get heads, this is one option, or you get tails, which is another option. So that means that there are two total outcomes, two possible outcomes when you flip a coin. So two outcomes. So if we want to calculate the chance or probability of flipping a coin and getting heads, it would be 1 out of 2, because there's one option out of two total options, which is 0.5, or also 50%. So the same thing goes for tails, because there's only two options here. If we flip a coin, the chance of getting tails is also one option out of two, so 50%. So when we flip a coin, 50% of the time we can expect to get heads, and the other 50% is tails. Now, this is where probability gets a little tricky, right? Because we've all probably flipped a coin a number of times, and you're not going to get heads 50% of the time and tails 50% of the time. If you flip them enough times, it will roughly even out. And yes, I have had to do this for a class. You'll get something between 48 and 52% typically if you flip it like 100 times. And the more you flip it, the closer it'll get to 50%. But this is why probability is a little tricky, because it's not necessarily reality. Some things that are very, very, very unlikely will still happen, especially when you have 8 billion people out there. Some things that are very, very, very likely may not happen. However, probability is really, really useful for understanding the behavior of certain systems. So let's look at what happens when we flip a coin multiple times. Okay, so let's say I flip a coin 500 times, and something wild happens, and out of those 500 times, I get heads every single time. Now, my intuition would be like, girl, when you flip that coin, you are going to get tails the next time. But wait, the probability of getting heads or tails for each successive flip, for each next flip of the coin, is still the same 50%. So this is why probability is not intuitive. Even if I flip a coin 500 times and get heads every single time, the chance that I will get heads the next time is still 50%. It's still 1 out of 2. Because that event is independent. It does not matter what has happened in the past. It's independent of all of my prior flips. And so the probability stays the same. Wild, right? And you're like, wait, that doesn't make sense because the probability of getting heads 500 times is so unlikely. Yes, accurate. But now we are talking about a dependent event. And that's a very big difference when we look at something altogether versus one single event. So looking at one single event, the probability of getting heads or tails will always be 1 out of 2. But if we ask, what is the probability of getting heads 500 times? That's a very different question. Often, the question matters a lot. So now let's ask that. Let's start with a little bit of a simpler example. So what is the probability of getting heads 3 times in a row? Heads 3 times. Well, for this, now we're talking about events that depend on previous events. They are connected. And to calculate that, we multiply them together. And so this would be 1/2 times 1/2, or we'll do the little X sign for multiplication. I like the dot sign, but times 1/2. And this equals I'm gonna check my notes. Nope, just kidding. I remember it. 0.125 or 12.5%. So the probability that you would get heads 3 times in a row is 12.5%. Not impossible, not impossible, but a little improbable. So much lower than getting probabilities decrease if you start to connect events because now you are starting to multiply probabilities. Okay, so that's really, really key takeaway here. The difference between a single event that does not depend on the outcome of prior events versus the probability of connected events. Okay, so now we can ask, what is the probability P of heads 500 times? That's going to be 1/2 times 1/2 times 1/2 times 1/2, etc. 500 times. And a shorthand way to write that is, hold on, I'm going to run out of space here. A shorthand way to write that is 1/2 to the 500th power, which is a real small number. And if you are curious, get out your little calculator or a calculator app on your smartphone, because most calculators these days, and you will find that this is a very small number. It is 3.05 times 10 to the negative 151, which is basically 0. What do I mean when I say it's basically 0? Well, this number is so small. It has 150 zeros in front of the decimal point. So I would have to write 150 zeros this way to represent that number, and I'm really lazy, so I am not going to do that. I would certainly run out of chalk space, and I don't want to count that many. So basically, because the probability is so low, we can effectively round to 0 because it might as well be 0. It's so unlikely that it will probably never happen to me. Will it happen to somebody? Maybe. It's not impossible. So it is theoretically possible that out of the 8 billion people on this planet, if enough people sat down and flipped a coin 500 times, possibly one of those people would get heads 500 times in a row. Very unlikely. It's also not necessarily guaranteed that even if all 8 billion of us sat down and flipped a coin 500 times, maybe no one would get heads in a row 500 times. And again, that's why probability is really wild, because it is not necessarily what will happen. It is what is likely to happen. Very different. And that brings us back home to our key point, which is lottery tickets are very low probability of winning. And so because the probability is so low, if you're doing it for fun, okay, whatever. But if you're doing it because you actually want to win, you would be much better served by taking that $1 or whatever it is you spend and putting it in the stock market or putting it into a high yield savings account, because you will be guaranteed to make more money off of that $1 than you will in the lottery, because the likelihood of you winning is so low, it's effectively zero. Full stop. So that's not to say if it brings you joy, if you have fun doing it. I bought lottery tickets a couple of times. I won $3. Each of my friends, we had $1. We bought a lottery ticket. I won $3, so I gave a dollar to each of my friends, and it was like we broke even. It was cute. It was a little fun thing for us to do, and we weren't really sure what we wanted to do. I think we probably bought slushies or something. So if it brings you joy, cool. But I think it's really important to understand why we do the things that we do, and to also understand how these types of systems work. And probability is a really, really good way for understanding systems. Okay, I'm going to leave you with a little like, ooh, let's do a probability example together, okay? Yeah, let's test our knowledge, because you're smart and you can learn things. So let's check what we have learned. Okay, so we're going to erase the board and do something a little different, but still familiar, especially to my nerdy friends that play D&D, except we're going to use a smaller die. Actually, a lot of y'all probably play board games, so it's not just my nerdy D&D friends. Okay, so let's say we have a 6-sided die. 6-sided die, or dice, whatever. What is the probability of rolling a 3? So probability of rolling a 3. I'll give you a second to think about it. You can pause the video too if you prefer. And if you would like a hint, if you don't want a hint, pause the video. My hint number 1, is that there are 6 total outcomes. Yeah, 6 total outcomes. Okay, so if we're going to write a fraction, it would be out of 6, because there's 6 options. Hint number 2 is that rolling a 3 is 1 option out of 6. Okay, are you ready? You're a smart cookie. You probably figured it out by now. You're like, come on, get to it. Let me check my work. The answer key is important to know that your knowledge is being applied accurately. So the probability of rolling a 3 is 1 option out of 6. Ta-da! So the probability of getting a 3 is 1 out of 6, which is about 17%. I think it's like 16.7% or something like that. Cool. Okay, let's do a second one with a little bit less time and no hints. Okay, what is the probability of rolling a 6? Bring Mama Llama back. Mama Llama, what do you think? Well, there are 6 outcomes, and rolling a 6 is 1 outcome out of 6, so it's the same. Yes! Yes! Jasper agrees. Bark, bark, bark. So it's the same. It's still 1 outcome out of 6 total possible outcomes, so it's about 17%. My squiggly equal sign is about. Okay, cool. So sometimes it can trip you up because you're like, 6, it's 6 out of 6. 1, no, wait, hold on. So remember to apply your reasoning, right? How many total outcomes are there? That goes on the bottom. How, and then, how many outcomes are you asking the probability for? And let's do a slightly different example so that you can see what I mean by that. So for example, if I ask, what is the probability of rolling a 2 or a 6? 2 or 6. Now we're asking about 2 outcomes out of 6 possible outcomes. So now it's 2 out of 6, which is 1/3, which is 33%. So it's more likely, 33% in this cute little lime green, more likely than just the probability of a single outcome. Okay, so fun. Probability is amazing. It shows up everywhere, including quantum mechanics, which is wild. And this is why physicists, when they discovered quantum mechanics, their brains were like, what? Because quantum mechanics implies that the universe is non deterministic, that everything is a probability, which means that we can't necessarily say for certain. And when I say this, I mean we are talking about the atomic level. Um Not necessarily the universe that we experience, but the universe that particles experience is very wild and probabilistic, which means you might make the same measurement over and over and over again, and you might get a different result every single time with everything else being the same. Versus if you're doing an experiment in traditional science, in our universe, like if I throw the ball with the same amount of force and I have the same conditions, the ball will hit the same place every single time. But that's not so with particles. Sometimes the particle goes through the wall, or sometimes it just like poof, you're like, where'd it go? It's so cool. I love it. So probability, it's weird and wild and wonderful and very useful. And the important thing is to understand how to apply it. So keep in mind single events that are independent, that exist in their own little space, do not depend on anything else. And then dependent events or connected events, things that depend on prior events, are very different. And just remember, how many total outcomes are we talking about? How many outcomes are you asking for the probability? And then using our handy dandy skills of division to figure out what the probability of that outcome is. Okay, I hope that was helpful and fun. Please let me know if you have any questions about probability or other science, tech, engineering, and math topics, because learning is amazing. This universe is just stupendous, and it's really lovely to know more about the weird and wild world that we live in. Alliteration. Cute. All right. Thank you very much for hanging out, my dear friends, and we'll see you next time. Bye.